So dear students, in this second video, we are going to discuss Newton's first law of motion. Chapter's name is Force and Laws of Motion, Physics, class 9th. So Newton's first law of motion states that if any object is kept in the position of rest, then it shall remain in the position of rest always. And if any object is moving, then it shall always be moving until or unless any external unbalanced force is applied on it. Means suppose this is the ground and we have a ball on the ground, then this ball remain at rest until or unless if we have to apply any unbalanced force. Suppose we apply unbalanced force in this direction, then the ball will start moving in the particular direction of the unbalanced force. Or if any object is moving, then it shall always be in the state of motion until or unless any external unbalanced force is applied to stop that object. So this is the statement of the Newton's first law of motion. Suppose if any object is moving in the friction free zone, then it will always be in the state of motion until there might be some friction externally or any external force should be there to stop that object. Now there is a tendency of all the objects to resist or to oppose any change. All the objects have the tendency to resist or to oppose any change either in the position of rest or in the position of motion, and that tendency is called as inertia. So students, the first law of motion tells us about the inertia, and therefore this law is also called as law of inertia. Because this law deals with inertia. So what is inertia? Inertia is simply a tendency of all the objects to resist any change. Now inertia is of three types. Number one, inertia of rest. Number two, inertia of motion. And number three, inertia of direction. Now let us have an example of inertia of rest. Suppose I am the passenger and I am standing in the bus by holding that rod and without holding that rod. Okay, I am standing like this in the bus. The driver started the bus and the bus started. So as I am standing like this in the bus, the driver started the bus start moving. Where shall I go? I will go in the backward direction. So actually I am not going in the backward direction. The bus is moving in the forward direction, and inertia, due to inertia, my body tends to remain in the position of rest. Okay. Now in case of inertia of motion, suppose I am again standing in the moving bus and suddenly a dog comes in front of the bus. The driver applied the brakes. Then what will happen? The bus will stop, but my body, due to inertia, it will move forward and I will fall in the forward direction. Similarly, we can also take some examples. Suppose this is the floor mat laden with the dust. It has dust particles. Now what will happen if I hurt it like this? If I hit it like this, what will happen? The dust particles moves out. Why? Because when I hit it like this, suddenly due to the impulsive force, this carpet will move in the forward direction and dust will remain here due to inertia of rest. This carpet will move in the forward direction and dust will remain here. Now what will happen if I take this dust laden carpet and like this I make it allowed to fall on the ground? On striking the ground, the carpet will stop, but the dust particles present inside it, they keep on moving. So we see that the dust particles comes out of the carpet. This is due to inertia of motion. Inertia of direction is the third type of inertia, in which we can have an example. Suppose you are sitting in the middle position of the rear seat of your car, and suddenly your driver tilt the car to the right side, then what you will experience? You will experience there might be some force which is tilting you towards the left direction, because the car is moving towards right and your body wants to remain in the straight line. That is why due to the resultant force you feel that your body is tilting towards left, but actually your body tends to remain in the same straight direction. Now dear students, I want to tell you that inertia always depends on mass. More will be the mass of the body, more will be the inertia. Let us have an example. We have a truck on the road and we have a scooter on the road. If you are pushing the truck, can you push the truck? We cannot push the truck alone, because the truck has very much mass, and more mass means more inertia of rest. It wants to remain in the position of rest. But in case of a scooter, a small student can also push the scooter, because it is having less mass. So due to less mass, it is having less inertia. So inertia always depends on mass. Now let us have another example. If we have a glass, and on this glass I have placed a playing card. This is the playing card. Playing card, you know, tash ke patte. So this is the playing card, and on this playing card I have placed very lightweight coin, very lightweight coin. Now what will happen if I hit the card like this? We see that most of the times the card flew off, and along with this playing card, most of the times that very light weighted coin also flew off, because the weight of that coin is very light. So very light means less mass means less inertia of rest. Now if I place a 5 rupee coin, a heavier coin on this card, and again I want to try to flew this card, then what will happen? And most of the times we are able to see that card will blow off and the coin will go inside the glass, because in the second case, when we have used the 5 rupee coin, the coin has much more mass. More mass means more inertia of rest. So finally we can say that the inertia of any object depends on its mass. So that's all for today. Thank you very much.